How's it going, everyone? I'm Paul. I've had 2 coffees and I am wired, which is good because I've got a lot of content to go through. So I work at AWS. I started off my career around 15 years ago as a developer. And I moved through a variety of ops roles and SRE type roles through to system architecture. I've worked at AWS for the last couple of years, and I think I've got a really cool job. I get to speak to all the development teams at Amazon, and I get to speak to some of the largest enterprises in the world and some of the coolest startups in the world and talk to them about CICD and DevTools and how they do them, etc. And then come and talk to people like you at conferences and try and meld together all those best practices I've learned. Cool. So we're here to talk about scale, and this doesn't have much to do with the rest of my presentation, but I heard this number recently and I thought it was really cool as an indication of scale that Amazon are working at. So in 2015, AWS deployed almost enough server capacity, servers, infrastructure, hardware, network gear, power stations, etc., to support Amazon.com when it was an $8.5 billion business. So if you imagine how much infrastructure it takes to run an $8.5 billion business, that's what we add into our data centers every single day of the week. Cool. So with that aside, I'm going to talk to you today about some of the most common challenges I see around CICD and dev tooling. I'm going to give you a bit of a history into Amazon's journey. Right? We came from a very monolithic background. We didn't have great tooling, etc., and that was a journey that we took. So I want to try and convey some of that journey and some of the learnings. I'm going to talk about some internal tooling and practices and best practices that we use within Amazon, and then how that translates into public tooling that is exposed through AWS and that customers can use today. So I hear this a lot. Okay, I speak to a lot of companies that want to move a lot faster, but there's a lot of excuses out there. We're too busy. We want to innovate. Startups, disruptors in the market are innovating, but we're too busy. And there's a couple of reasons I hear over and over again for this. First of all, it's a world of conflicting priorities in many organizations. So developers are paid to change things. That's literally developers' job. Security are paid to prevent risk. Quite often, any new development is new risk. Operations, if there's separate operations teams, they're paid to keep things stable. Any new development changes are potentially something that's going to wake them up in the middle of the night. So when you actually look into where time is spent in most release cycles, a lot of the time actually is not in the individual workstations here, so testing and development and actually writing the code. The majority of the time sits in the middle where those clocks are. And people have backlogs and work logs, etc. And when you have a lot of manual processes in there, those can grow exponentially. Typically, we tend to see that in an organization when everybody's too busy firefighting and trying to keep the lights on and business as usual kind of activities, you tend to build up these big backlogs of work when automation's not there, and you lose visibility and the ability to prioritize your workloads. In addition to that, if you're an organization that has large release cycles, so quarterly, 6-monthly, annual type release cycles of your software, typically these releases are going to contain a lot of things. Right? Everyone's going to get scared about what's in that release. No one's going to want to take on that risk of pressing the button. And you end up in these kind of gate processes of analysis paralysis and fear of change. Okay, so with that in mind, I want to do a bit of a retrospective on development at Amazon and a bit of a look behind the scenes at the journey we took. Does anyone know where that is? Anyone? Natural History Museum, exactly. Okay. So Amazon used to be this huge, great big monolithic application, like the .com retail side of the business, great big monolithic application, huge compile times, huge executable. And it was problematic for us, right? We had a centralized deployment team that was responsible for aggregating and deploying all of the changes from many, many development teams across Amazon. And I like this picture of a monolith because it kind of summarizes what happens when you keep on bolting stuff on top of a monolithic architecture. Eventually, it's going to fall in the sea. Startups, disruptors are going to come in and they're going to take your place. So we knew things needed to change. We were really suffering with this type of architecture. So this was back in 2001, and we knew we needed to change not only our technology, but also the way we organized our company as well. So we had these sort of monolithic development org and a separate ops org, etc. So we moved to what we called at the time primitives, now known as something more commonly as microservices, but the idea of lots and lots of small services. And don't worry, this isn't going to be a talk on the benefits of microservices, etc. I think we've all heard that to death. But we made this transition to small services, microservices, all with APIs and standard contracts. Around the same time, we did something else as well. So we knew that our org structure wasn't really working for the type of development agility we needed. So we moved to something we called two-pizza teams. And this is the idea and the concept within Amazon that no team should be bigger than can be fed by two pizzas. And it's kind of deliberately ambiguous because you get different sized people and different sized pizzas, and it generally means around 8 to 10 people. And what this did was decentralize our teams within Amazon and turn us into an organization of lots and lots of small startups that had ownership over their microservices, right from development through testing, operations, deployment, etc. And it just meant that all those teams could move a lot faster. This is the result. So this is an actual diagram of Amazon.com, the retail site, back in 2009, and all of the microservices, the pink and blue blobs here that made it up. So I've tried to find a more up-to-date diagram. I don't think it exists. I dread to think how huge it would be now. But this is the result. And this worked well, right? It allowed us to move a lot faster around that 2009 timeframe. But there was still room for improvement. We weren't hitting that sweet spot yet. So in 2009, we conducted a study to talk through, find out our inefficiencies, and look how long it took for code to get from a developer workstation through to production. What we found is that for a lot of it, we were just waiting. Right? We had a lot of manual processes. There were a lot of tickets flying back and forth for doing releases, a lot of manual gates, etc. And actually, if you broke this down, the actual writing the code and building and testing and deploying was nothing in the grand scheme of things, right? I've signified it as minutes here, and the actual days were spent waiting. And that meant that we were looking at weeks to get a change from a developer laptop through to production. If we could remove these manual steps and this waiting for other teams everywhere, we can drop this down, right? So to do this, we needed new tooling. The tools we had weren't geared up to moving fast back then. So there's a couple of tenets we used around designing good CICD type tooling. First of all, the tooling needs to be decentralized and self-service. So the day a developer needs to email someone to spin up a server or not work through that self-service model, we failed. So decentralized self-service tooling is really important. As builders of CI/CD tooling, you've got a great opportunity to put in place best practices across your organization. Maybe things like automatically having static analysis in a CI/CD pipeline to keep your security teams happy. Maybe blueprints for pre-approved architectures that get you 80% of the way through a security review. Those kind of things. So CI/CD is a great opportunity to build in best practices. Good tooling needs to be technology agnostic. Times change. Within Amazon, we have many, many different programming languages used. We have a lot of Java, we have a lot of Ruby still, but teams are free to use pretty much any language they want. So the tooling that we have in place needs to be technology agnostic. Otherwise, people are just going to create their own. And that kind of brings me on to this point, that good tooling, the number one rule, is that it should be the path of least resistance. If you put yourself in a developer in your organization's point of view and think, how do I start a new project? How do I build my CI/CD pipeline? If the standardized solution is too complex, people are just going to do it themselves. And you're losing out on that opportunity to bring some uniformity. So we built a tool more than a decade ago now called Pipelines. And this is our CI/CD pipeline tool. It orchestrates code from one place to the next. Right? This is something that probably most people in the room are familiar with, the concept of pipelines. It wasn't so common back then. But it takes code from check-in to production and everywhere through. We built another tool called Apollo, and this handles our deployments. So it takes an artifact, doesn't matter what type of binary, what programming language, etc. It takes an artifact, and it's responsible for deploying it. And it can do strategies like rolling zero downtime deployments, and it can do strategies like blue-green, etc. It does health checking and metric collection and automatic rollback, etc., if need be. So this is Apollo. This is an example of an actual pipeline within Amazon, just so that you can try and visualize it. I'm sorry if you can't read that. It's kind of deliberately potato quality because I'm not allowed to actually show you the real pipeline. So, but just so that you can get an idea of what a pipeline might look like within Amazon. So deploying to different environments and running different automated testing, for example. And while we're building these tools, we put together some best practices within our dev organization. So CICD is a must. That's pretty obvious, right? We want to get those automation benefits. Commit frequently and build on every single commit. Only build once in each execution flow. So if you're deploying to multiple different environments, don't build for each environment. You want that one consistent build that you carry through your CI/CD chain. Everything goes into a repo. This may seem super obvious as well, but in this day and age with cloud, etc., your infrastructure can be defined as code, put inside a repo, put inside its own CI/CD pipeline, and run automation tests on your infrastructure. Things like, have I opened up a port to the outside world that's attached to a database server or something? All these things can be automated and ticked off in CI/CD if you're hitting that infrastructure as code. Start with continuous delivery, right? So the concept of having a manual approval stage. So a lot of times if you don't have confidence in your testing yet, you may need that manual approval phase in your pipeline before your business is comfortable that you're good at detecting what a good deployment looks like, good from rolling back, good at doing testing to make sure bugs aren't getting through to production. So that's fine, but you should ultimately be striving to get rid of that and have a full automated pipeline. The last best practice is around deployment and how we tend to do deployments within Amazon. So typically a very common pattern for us is deploy to a canary, right? We call it a one box internally at Amazon. And this is the concept that you have a fleet of servers or instances, and you deploy to one of them, and a small percentage of your traffic goes to that canary. And you use that to gather metrics and data and decide whether to continue with the rollout or not, or to pause it and maybe roll back. The net result of this is that we have thousands of development teams within Amazon, all working on microservices architectures, each with prod, gamma, staging, beta, etc. type environments. Most of them using continuous delivery. And this number's a couple of years old now, but it's 60 million deployments a year, roughly equates to around 1.9 deployments a second that we're doing. So this isn't builds, this is deployments. At this point, you might be thinking, cool. Right, this is all wonderful and everything, but how does this help me? So I'm going to talk through a few steps that you can apply within your organizations here to achieve these same things. So step one, shrink your deployments. This one's fairly obvious, right? The faster you're moving, the smaller your deployments are, the less dependencies you're going to have in that pipeline and chain with other teams and other services. There's a few questions I like to ask customers when I meet them for the first time, just to get a gauge of their agility in this area. So the first one here, how many deployments am I performing? On the left-hand side, we've got, we're doing a quarterly release cycle, and we have all the kind of gate and process and approval process that comes with that, and we're struggling. On the right-hand side, we do too many, we stop counting. Second question, how many are done out of hours? And I ask this because this is a really good indicator of how well you're doing with your deployment technologies. So are you making use of things like blue-green deployments, canary deployments, zero downtime deployments? The tooling and technologies have existed for a long time to do this, but many, many customers try to do their changes out of hours because it impacts customers less, etc. Actually, the companies that are doing well at this will typically do it in the middle of the day, because you know what? That's when most of the engineers are working, if something goes wrong. The last question is, how many of those changes suffer emergency rollbacks? And this is a good indication of test quality. Right? How many of those changes, how many of the bugs, are being caught in your CI/CD pipeline before they hit prod? So ultimately, you want to be striving for continuous deployment, fully automated, building test environments, tearing them down as you need to, deployment, etc., fully automated end-to-end. And the way you do that is to use metrics, good tooling, good testing, to gain trust within your organization, to move towards that full automation. Has a couple of nice benefits. So obviously, automation is going to reduce the risk of human error. It improves developer productivity. So when I first started as a developer, I joined an organization, had a horrific monolithic architecture, and I worked there for a year as a developer, and I didn't see a single line of code that I wrote get used by a customer, right? Their release cycle was just too slow, and it's pretty demoralizing when that happens. So by breaking down your delivery chunks into small microservices, small deployments, it allows people to see those changes much, much faster. Obviously, it helps you find bugs quicker. You know, if you're doing those big bang releases with 6 months worth of changes, it can be quite hard to work out where a particular bug has been introduced. And ultimately, the whole point of doing this is to deliver updates faster so that you can innovate as fast as other people in the market can, the startups of the world, and ultimately keep customers happy. Second step is to improve visibility. So in AWS, we have Code Pipeline. And this tool is based heavily on all of the learnings we took internally from building our pipelines tool. So it allows you to create these automated CICD flows, and it looks something like this, where you might have source, build, staging environments, maybe manual approvals in there if you need it. And this is a public AWS offering that you can use, and so anyone can just create one of these from the AWS console. Next, I want to talk about automation. And how to automate things. So I'm going to talk about two things here. First is how to automate your build and tests really easily. And the second is how to automate your infrastructure and application deployment as well. So hands up if you've ever worked at a company that was something like this, right? Where you had some sort of build server in a cupboard somewhere that Jeff set up many, many years ago, and no one's really touched it since, and no one really knows quite how it works. I know I have, not Amazon, I should say. So this is super common. There's no excuse for it in this day and age. CodeBuild is an AWS service that runs commands for you, at its most simplest. So it does your builds for you, and it does them at scale. Okay, so you tell CodeBuild, hey, I've got this kind of project. Maybe it's Android, Java, Python. We provide all the tool chains in a build environment. You can actually provide your own Docker container if you want to go custom. And we will run your builds at scale, and we charge you per minute that your builds are running. All a developer needs to do is describe their build process in a file within the repo, so the build spec file, and just say, hey, this is how you install, all the prerequisites. This is how you install my software and how you build it, and maybe here's how you run unit tests. Net result is you get these nice build results, and it integrates nicely into tools like Jenkins or Code Pipeline. Next up, infrastructure deployment. Similar thing. Who's worked at a company where your production environment looks something like this, right? Where it's this super sweet environment that people spend hours and hours tweaking and keeping working and optimizing, and then you look at your staging and test environments and they look something like this, right? So like something someone built in a school science fair. And I feel a bit bad here because I got this photo from Flickr, and this probably is someone's real science fair project, so sorry, children. I like the sign up there that says 0 days without an accident. I thought that was quite poignant. So again, there's no excuse for this in this day and age, right? Infrastructure as code, being able to deploy consistent environments in like a cookie cutter approach means it's really easy to have consistent environments across staging, test, and production. And that's a really good way of building trust, right? If you've got different environments, it's more likely bugs are going to slip through the net and only be found when they hit production. So within AWS, we have CloudFormation, which is our form of infrastructure as code, but there's plenty of others out there. This isn't a new concept. And it just allows you to describe all of your resources for an architecture as code, check it into the repo, and do CICD on your infrastructure. Cool, so how do I deploy my app? So I've done my architecture, my infrastructure. Again, we have a service called CodeDeploy. This service is built on all the learnings that we took from building Apollo inside Amazon over the last decade or more. And it receives an artifact, a zip file, with your code in, with your binary, or whatever you want to deploy. And it can deploy to Windows, Linux, EC2, on-premise, and it can validate deployments. And it's got built-in strategies for things like blue-green. So it can spin up a whole other environment and slowly migrate traffic across as you gain confidence in your metrics. It can do zero downtime rolling deployments as well. And again, you just have this configuration file in your repo where you tell it, hey, here's some hooks. So before installing, do this. After installing, do this. Here's how you stop and start my application. And here's how you validate it's running. So in this case, I've just used bash scripts and just hooked it out to bash scripts. You can use Python or whatever you want, PowerShell here. The validate one's probably the most interesting. So this is where you would do things like, at its simplest, use curl or something maybe, just to check that a web page is responding. But maybe you want to go deeper and look at latency metrics and actually get more of a feedback loop there. So the output you get, again, you get a nice managed screen, but it also integrates in pipeline tools and Jenkins and all those kind of toolings. So putting it all together, how do you get started with this today? We have a service called CodeStart introduced recently. If you take away one thing from this talk, it's the word CodeStart. This service allows you to create a new development project on AWS. You pick from a blueprint. These blueprints are both technology-based, programming language-based, and architecture-based. So you can say, I want a Node.js deployed to Lambda and serverless, or maybe to EC2, or maybe to some other form of technology there, some other architecture. You give it a name, and behind the scenes, this is going to set up a source repo for you. It's going to set up a build environment in CodeBuild. It's going to set up infrastructure as code with CloudFormation, like I showed you. It's going to set up monitoring within CloudWatch so you get that full feedback loop. It's going to show you how to integrate with existing IDEs and command line tools. It's just a Git repo at the end of the day that you're pushing to. And then eventually you get this dashboard, and it's going to be really hard to see here, but you get a pipeline set up for you, and you can modify this pipeline and customize it and put your own testing in and that kind of thing. It integrates metrics as well and Git history and stuff. But if you want to play around with CICD tooling on AWS, this will get you going in a couple of minutes. So just to summarize here, innovation requires agility. The enemy of agility is firefighting and large releases. So shrink your deployments, strive for continuous delivery. There's some tools there that can help in terms of CI/CD. And yeah, get started today. Have a play and build. That's me. Thank you, everyone.